So we're looking at the solutions for worksheet 7.6, 1E and 1F, and we'll look at the 22.3 numbers ones as well. So these are derivatives of inverse trig functions, and these are, we need to make sure we know these, or at least have a formula sheet for these. Okay, so the derivative of the inverse cos function gives us -1 over square root 1 minus x squared. Okay, so that's something we need to know. Okay, and we're going to use this for its integral as well. So when we differentiate this, so y prime is going to be equal to -1 over square root 1 minus x squared. So there's our derivative of the outside, but now we have to use chain rule. Okay, because the inside function of x cubed over 2, so we're going to end up with 2x squared over 2 using that chain rule. Okay, so then this simplifies to y prime equals, it looks like just -x squared over square root 1 minus x cubed over 2 squared. Okay, so same thing here, except we're going to have to apply product rule. So the derivative of arctan, we need to make sure we know the derivative of arctan. In the derivative of arctan, looks like this piece here is going to kind of match, looks like a little bit of derivative of arctan. So let's write the derivative of arctan. Okay, so we have d by dx of arctan of x, and that's going to be 1 over 1 plus x squared. Okay, there's a little bit fancier formula to this, but in general, this is what it looks like. And so when we differentiate this, we need to apply the chain rule, or sorry, the product rule. So we're going to differentiate this piece, okay, and then we leave the arctan plus 1 plus x squared times the derivative of arctan, which is going to be 1 over 1 plus x squared. Okay, so then this ends up canceling out. So we end up with 2x arctan x plus 1. Okay. Looking at 22.3. Okay, so 22.3, question number 1. So this is 22.3, number 1. Let's look at 1D. So this is the arcsine of square root 2x plus 1. Okay, so we need to know the derivative of arcsine, so d by dx of arcsine x. Okay, it's going to be equal to 1 over, it's going to look like this, 1 over square root 1 minus x squared. Okay, so arcsine and arccos are very similar, they just differ by the negative. And so when we actually integrate, we're just going to do it, we're not going to use both, we're just going to use arcsine. So differentiating the arcsine, then we're going to end up with the derivative y prime is going to be equal to 1 over square root 1 minus x squared. Okay, so there is an embedded function. So square root 2x plus 1. So we need to differentiate that square root function. And we also have to make sure we times that by 2 because of the 2x inside. Okay, and then simplifying this derivative then works out to be, looks like the square root, the 2's cancel out here. And then we end up with 1 over 1 minus 2x plus 1. So that looks like square root 2x. And that's over 1 over square root 2x plus 1. Okay, so just simplify that a little bit more. It becomes square root of negative 2x over. Okay, so we could kind of combine that. I'm just going to leave it like that. Well, I suppose we could just multiply it in. It's going to be square root negative 4x squared minus 2x. Okay, so there's our derivative function. Okay, just double checking. I think I got the negatives right here. Okay, looks like the negatives are right. Yeah, x squared, square root. Yeah. Okay. So for 22.3, that's D. Okay, number 1, E. Okay, it's the arc cos, so the derivative y equals the arc cos of x squared minus 1. So again, we want to go to our formula. Our formula is this one here, so it's negative 1 over 1 square root 1 minus x squared. Okay, so it's going to be negative 1 over square root 1 minus x squared. Okay, the embedded function, we need to make sure we apply the chain rule to that. X squared minus 1, so times 2x for my chain rule. Okay, and then we end up with negative 2x over square root of 1 minus, I'm just going to leave it in brackets here, x squared minus 1. Okay. And then for 1f, it's the arctan. So arctan x squared. So y prime is going to be 1 over 1 plus x squared times, we need to make sure we apply the chain rule again. So there's an x squared inside. So apply chain rule times 2x. Okay, so the y prime then equals 2x 1 plus x to the power of 4. Okay, so the idea is that we have to, when we run into these derivatives of these functions, we need to then use our defined derivatives, arc sine here, arc cos here, arctan here, and again, these are just defined derivatives. We need to know them or have them on a formula sheet. Otherwise, we're not going to generate these on our own, or we could, but we want to avoid that by just knowing these.